So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So my name is Neeraj Kheria. So the main agenda for today's session is we'll be discussing on what exactly is Python, what are Python features available, right? And who exactly uses Python, what are the different libraries available in Python, right? And then how to get started on using those libraries as per part of our use case here, right? Now, Python, as you know, is one of the most popular languages all around the globe. And again, it is one of the most widely used language as well as compared to any other language. If we compare Python with Java, with C, .NET, PHP, again, these all are Python is one of the most popular language out there, right? And one by one, again, it is replacing each and every language that we have available as a part of this entire IT domain, right? And there are multiple reasons of. First of all, it was created by Van Rossum in back in 1989, right? And that's why it was mainly inspired by his favorite shows, Monty Python, right? And it is generally we can say it's a general purpose application where we have the features of like we have high level interpreted languages with the easiest syntax and dynamic semantics because in terms of the grammar, as we know, Python has the least amount of grammar as compared to any other languages, right? For a simple example, is suppose if we are trying to print any statement, then suppose in Java we have to write system.out.println and then we have to define the content which we want to get printed. Whereas in Python, we simply have to use a simple print command. Nothing, no system.out.println or anything. It's a simple English print, and then we can define the message that we are trying to print here. As simple as that, and that too without the use of any kind of semicolon towards the end, right? And Python again has has basically first of all is the easiest language to start with, right? And Python has a huge now first of all in terms of the easiness, again it has the least amount of grammar, correct? Then obviously it is again an open source application, open source programming language. That means again we don't have, there are no licenses involved here. It is absolutely free of cost, right? And then it is portable. That means it can be written in one system and it can be executed in the other without any hassles, right? So for example, when we are building any code on Java, obviously when we are writing any code in Java, obviously we do have to write the code. We also have to attach all the libraries, all the supporting libraries for it, and then and then only that code can be executed in some other systems, right? Whereas in here we don't have any dependencies of that kind. We don't have any kind of dependencies of that kind. So that means we can simply write and deploy the codes on any system. That gives an added advantage to Python as compared to any other programming language out there, right? Then in terms of embedded, again, Python allows code of other languages such as C, C++ to be embedded into it. So that's now, for example, if we have some functions and classes defined in some other code, right? Again, in some other language, still we can import that easily as a part of the Python infrastructure. We can define that. And then obviously it is interpreted. That means again the entire CPU and memory management. Again, these things are handled by Python itself, so there are no involvements here. Then it has huge. Now, this is the main advantage that we get as a part of this entire working with entire library, or we can say Python infrastructure. They are huge. There is a huge amount of library available in Python, which is specifically built for the purpose of data manipulation and for multiple automation scenarios, right? So in here, since we have multiple libraries available, we can it simply makes sure that it simply is easing out the entire job for us, right? For example, if we have to write 20 lines of code in Java to manipulate any data, then same thing can be done in just 2 lines of code using multiple libraries available in Python. That's how easy it is. And then at the end, it is object oriented. That means again, the entire object orientation helps break down complex problems, just like we have the entire OOPS concept on which the entire Java is built on. Same way we have the OOPS concept available in Python that simply makes the entire job much easier for us, right? And again, the main simplicity again. That's why these are now in terms of the use cases available for Python. Again, there are multiple use cases here, right? So again, the Python, as we know, is one of the we can say one of the main driving languages, or we can say driving force of different applications all around the globe, which includes Google, Dropbox, BitTorrent, NASA, Raspberry Pi, Netflix, YouTube. So these all we have the NCA, right? So these all agencies, these all companies, they have been using Python as one of the main driving force, and that's why they are so much efficient in the manner the entire data is being interpreted, right? Now, if we talk about the entire libraries that we have to focus on, again, there are multiple libraries that we can focus on, starting with, now we do have multiple libraries available, right? Now we do have, like we have Skikit, we have TensorFlow, we have Pandas. So there are multiple libraries available out there that we'll be focusing on step by step, right? So first of all, in order to start with Python, first of all, let me showcase you how we can do the entire installation for Python first. Now, in order to start with the Python, first of all, we do need to have an IDE installed for Python, right? So what we can do, we can use there are multiple IDEs available which are popular in terms of Python development. So we can use IDE like we have PyCharm, where PyCharm is the most popular IDE specific for the purpose of development on top of Python. So we can use PyCharm. So PyCharm is available for both for Mac and as well as Windows as well. So we can use this link. We can click on download, and there are two versions available for PyCharm. We have professional and then we have community. So our main focus is only to develop on top of Python, right? We don't need any kind of other integrations or developments to be done. We can go ahead and download community, which is absolutely free of cost for lifetime. Or if we are looking to develop, or we can say develop entire application where we need to have integration done with HTML, JavaScript, and SQL support, then we do need the professional version, which is again offered to us on a license basis, and that will is currently being charged. Now, again, we are not paying for Python, we are paying for IDE, for this integrated development environment, which will make the entire process of development easier for us. So depending upon our requirement, we can choose among any of these languages or any of these we can say variations here. We can do that. So now for downloading the community version, we can simply click on download, and then we will be having our entire version being available to us. For example, let me showcase you how exactly PyCharm's community version looks like. So we can open it up once we have successfully downloaded and installed it. Now, just like we have any other languages here, we can simply start by creating a new project. So in here, we can click on File, New Project. We can define the new project that we are trying to create here, correct? And then we can get started, just like we create any project in any particular file system, right? So here we can define the project name. Here we can choose which variations of Java, or we can say which versions of Java we want to use here. We can define the entire environment in which we want to develop, and then we can get started, right? So for example, in here, we want to call this program as Edureka itself, Edureka. So you can define the name as Edureka. We can choose to open this up in a new window. It will simply create the entire virtual environment here, and then we can start with our new project called Edureka that we have created just now. All right. Now, once we have this entire link downloaded, then we can start with our own project that, as you can see here, right? Now the project has been created. Now, if we want to get started, we can simply click on new. Suppose we want to have this, we want to simply create a Python file that we are trying to execute here, right? We can simply create a Python file here, and then we can get started. Suppose in here we want to get started here, we can simply start writing the code as a part of Python programming here, right? Now the first library that we are focusing here is Pandas, right? So I'm sure you all must be aware on how we can install PyCharm and how to configure and create a new project out there on top of PyCharm, right? So now let's just start our discussion on multiple libraries available in Python, right? So first of all, in terms of the first library, we have Pandas, right? So Pandas is basically a machine learning library and a simple ML library available in Python that provides data structures for high level and a wide variety of tools for analysis, right? Now, the main feature for this library is simply it allows us to translate complex operations with data using one or two commands. And there are multiple inbuilt methods for grouping, combining data, filtering, and for carrying out all the time series functionality as a part of Pandas, right? And it simply now what Pandas do, it simply makes sure that the entire process of manipulating data becomes much easier, right? And that's why it supports reindexing, iteration, sorting, aggregation, visualizations. Again, these all are the common features available as a part of Pandas itself, right? And basically, if we talk about the use case for Panda, again, it is basically used for adding new features when we are trying to fix any of the bugs in the applications. We are trying to enhance the functionality. We want to change the APIs, right? And now, basically, in terms of the in regard again, its ability to group and sort data, these are basically used for data analysis, right? And when we're using the Pandas library, right? But again, we can also use Pandas with other libraries and tools to make sure that the entire high-end functionality and the flexibility is maintained for the applications. That's why we use Pandas for, right? And Pandas again, they can use for slicing the data frames. It can be used for changing the index, data conversion, joining and merging, concatenation, changing the column headers as a part of the entire Pandas library. And again, first of all, before we can get started on Pandas, we do have to make sure that we are able to include Pandas first of all as a part of the library is available in Python altogether. So now for installing the library here for installing the library, we can simply we can come back to our IDE. In here we can go to file. Under file here we can simply go to the settings, right? And in here we can go for interpreter, like we have a project interpreter. So in here we can choose which particular interpreter we want to use here, right? So in here we can choose, suppose here we want to use this interpreter, and again in this interpreter if we wish to add more libraries, we can choose the library which we want to install here. Just a moment. And here we can search for any library that we want to install here. For example, currently we are looking to download and install Pandas, right? So here we can choose Pandas library. Here we can choose a specific version that we are trying to install here. For example, in here we can specify the version that we have from 1 to 0.025. We can choose between any versions, right? And then here we have simply click on install package. So once we click on install package here, this will simply automatically install the package available on the Python repository here, and this will download and install the package automatically into our own system. It may take a couple of minutes. For doing that. But again, as soon as the entire library has been installed, now we can get started working on it. As you can see, it may take from a couple of seconds to multiple minutes as well. All right, so now once we have the entire packages installed here, we can simply come back and then we can start using that particular libraries back into our use case here. We can do that. So as you can see now, the Pandas library has already been installed here successfully. So now we can get started on using this Pandas library that we want to use as a part of an entire hands-on project, right? So in here we can define, suppose that we want to start importing Pandas, right? Suppose we want to simply we want to create any data frame here, right? Then we can use Pandas. We can simply use Pandas for creating that particular data frame that we are interested in, and then we can get started on top of it. We can easily do that, right? For example, suppose if we want to get started here, we can simply write a simple command statement as import pandas. Here pandas as PD. Here we can define the entire statement here. Now suppose here we want to create a simple data frame here, right? So here we can define this as data frame, right? And we want to call this as data frame as suppose PD dot data frame that we are trying to create here as a part of data frame. And then suppose if we want to if not here, we can simply import any data frame here, right? Suppose say instead of data frame here, we can name it as df1, for example, the first data frame here. We can simply now here we can simply use the command as df1 to print the entire data frame altogether, right? And now suppose if we wish to run this command here, we can simply right click on anywhere on the interpreter, and then we can simply click on run, right? And suppose if we want to create any data frame as a part of the list as well, we can simply define the entire list altogether. We can simply define the entire list, such as in here, instead of importing any particular data frame here, what we can do, we can simply define one data frame here. So for example, let's say here we have an array, right? Here we have a single list with us available as a part of the entire array, right? For example, here we have a list of 1, 2, 3, 4, 5. Here we have an entire list here, right? And now we want to create the data frame using the same data that we have currently created, right? So again, we can simply right click here, we can simply execute the entire command, and then we'll be able to see the entire data frame being available to us. Started with the pandas here, and after pandas, what we have another library called as NumPy. We have another library called as NumPy. So NumPy is basically used for performing the scientific calculation that we have, right? So basically, if we are looking to perform multiple scientific calculations, then we can use NumPy in those cases, right? So NumPy is basically now just like we have pandas for creating data frames, we have NumPy, which is one of the most popular machine learning library in Python. And now we have other libraries available such as TensorFlow as well. So TensorFlow and all the other libraries, they also use NumPy internally for making sure the entire operation, if they have multiple operations, or now they can easily perform using the concepts of tensors, right? And the array interface again is the best and the most important feature for any NumPy, right? And why we use NumPy, basically it is more interactive, right? So basically we use NumPy because again it is more interactive, right? Again, it is much easier for us to use as well. It offers us the capacity, or we can say ability, to perform multiple mathematical calculations, right? It is intuitive. That means the coding is for in NumPy is much easier, and there are a lot of interaction that is being applied as a part of NumPy library, right? And in terms of use cases, basically the entire interface can be used for expressing images, sound waves, and other binary raw streams often, or we can say which is again developed as an array of real numbers in the n-dimensional scenarios. And these are basically used for machine learning, for the implementation of machine learning. And that's why it is a must for anyone in the working in the ML domain to have a good knowledge of NumPy, right? And that's why that's why this library is available as a part of top 10 libraries in Python altogether. And same way like we have imported back pandas, same way here we can get started on NumPy as well. So here we can simply click on other settings. Here we can simply go to the settings here. Here we have to add the library. So in here we can again search for a library named as NumPy. We can search for NumPy, click on install package, and this will install the package for us that we can use to get started. So as you can see, NumPy has been successfully installed, right? So in here we can see now here we have the entire URL for the entire NumPy installed here that we can start using it. So as you can see now here we have the specific version for 1.18 for which we have currently installed here, right? So here we can click on OK, and now if you wish to start working on NumPy, we can simply define any particular use cases for NumPy easily, same way like we have seen for pandas. Same way here we have multiple use cases available for NumPy itself. A simple example is, suppose say here we want to go ahead and we want to print multiple dimensional arrays here, right? So what we can do is we can simply start by defining the NumPy library. Here we can use import NumPy. We can use NumPy as np. Then we can create a simple array consisting of, we can create a simple two-dimensional array here. We can do that. Now, since we have the NumPy installed here, now we can use NumPy for creating the entire array here. For example, in here, we want to create a simple array here using NumPy library. Here we can define NumPy array, and then we can keep on defining. Suppose we wanted to use a simple array. For example, here we have an array for 1, 2, 3, right? And then we want to use another set of array here as a part of two-dimensional array. We have 4, 5, 6. We have 4, 5, 6 here as a two-dimensional array that we are trying to add here, right? Now, suppose let's say here we are trying to simply print the array object. Suppose here we are trying to print array object, right? Then what we can do, we can simply use the concept of print as a print statement, and then here we can define the array. For example, here we can write a statement as array type, and then in terms of array type here, we can define what kind of type we are trying to define here. We can define type, and then we can define the type of array that we currently created. Right, so this is how we can define the entire type here. Same way, if we want to print array dimensions, suppose here we are trying to print array. Okay, so array dimensions. Here we are trying to print array dimensions, and again we can use print, and then we can define dimensions, and under dimensions we can simply use array dot dimension. So simply get this entirely printed, right? And same way, suppose if we are also looking to print the shape of the array as well, print shape of array, we can use the command as print. Again, we can use print, and then under print we can define the value here. Under print we can define the value, what exactly we are trying to print here. We are simply trying to in here, we suppose if we are trying to print something as shape. Now, if we were trying to print something as shape, we can define this as array and shape. So same way here we can print shape, we can print the size of the array as well, or we can simply define the elements in the arrays as well, exactly as per a requirement, right? And suppose if we simply execute this, as you can see here, currently we have array type is we have the class NumPy.an array, dimensions, it is a two-dimensional array, and then we have shape defined as 2 and 3. Right, and same way if we want to create the array here, now we can use this for array creation as well. If we want looking to simply go for array indexing, again we can simply define this for array indexing as well as a part of performing any particular calculation. We can easily do that. And then just like we have discussed on NumPy, we all have multiple other libraries also available, right? So after NumPy, we have libraries like we have Matplotlib. Suppose if we are trying to plot any particular data set into Python, for example, we have a given data set and now we want to plot bar graphs, histogram, pie plot, hexagonal plot here. We want to plot area plot. We want to go for scatter plot, right? So these things can be easily done by using the Matplotlib library, which is basically used for, again, which is one of the most popular libraries used by data analysts, by data analytics and data science team for making sure that they are able to present the reports in the most visual format possible using the Matplotlib library here as a part of Python. So for example, if you want to see some sample plots, we want to see some sample plots execution in a Python. Let's go ahead and see that. Now for seeing that, we can come back to our entire PyCharm here. Now in here, suppose here we are trying to plot a simple graph here, right? We are trying to plot a simple graph here. And what we can do, we can simply use the same like we have been using multiple other interpreters. We simply have to first of all install Matplotlib library here. We can simply define Matplotlib, click on install package, or whenever we define any library here, we can install it directly as well by using Matplotlib, right? So currently, as you can see, if it is not installed properly, we can simply press Alt Shift Enter to install the current library here. So what it will do, so it will simply make sure that we are able to install the library. As you can see, currently Matplotlib has been currently installed here, right? And once it gets installed, again, this can be used for our requirement here. And again, here we can simply use import pyplot as suppose we want to import this as plot itself, right? So here we can simply use, okay, from, because again here we want to use from Matplotlib, we want to import pyplot. So let's wait for these packages to be installed one by one. So currently we are installing pyplot and Matplotlib both. Now then we can, here we also have, we need from Matplotlib, we want to import style as well. If you want to have some styling components also imported here. And then in here we can use style.use. We can simply use something such as suppose graph plot, right? So here we can use ggplot that we are trying to use here. In here, suppose if we have multiple data sets, for example, from X, so in X here we can define we have certain data set. For example, in here we have 8, we have 4, and then we have 9. Suppose we have these kind of data sets from X here. We have 3 plots. We have 3 different data set that we need to plot on a graph here, right? So for example, here we have X. In Y, we have something such as 15, 5, and then 7, right? And then in terms of Z, we can use, something as suppose 6, 12, and 4, right? So here we have 3 data sets available, 3 arrays, and now we want to use something as plot, right? So here we from plot, we can define we want to plot what? We want to plot X, Y, and then we want to simply use the G here. For example, in here we want to define a new line here as a part of the index value, right? So here we can define this as a Gplot that we are currently imported, right? Then we can define label. So now we want to define the label as suppose, let's say G of was, or we can name it as graph1, right? Or we can name it as slope1. So this will be used like a, we can see like we have legends, right? So this will be used like a legend altogether as slope1, right? And then we can define the styling of that particular line as well. We can define the styling of that line as well. We can easily do that. Let's use a single quote instead of double quote. And then we can define, now for defining the styling of that here, for example, we want to define the line width. We can define line width. We want to keep the line width at 3. We can define 3 here, right? Same way we can use plot.plot, plt.plot. Here we want to plot suppose Z. Let's use another, suppose so here we are using Z, and we have also Z1, Zn, Z1 here. Now in here in Z1 we also want to define something suppose as 6, then maybe 9, and then we have another 9, right? And in here we want to plot Z, we want to plot Z and Z1. Or suppose let's name it as Z2 and Z1 just to avoid confusion. We have Z1 and Z2 that we are trying to plot here. We have Z1 and Z2. And same way here, we also want to define a simple label, right? So here, suppose here we can name it as C. We can define any label here. And then under label, we can define this as slope2. Slope2 here. We can define it as slope2. And then we can define the condition. So here we can, here if we want, we can define the line width suppose as 3 again. So here we have label, and then we can define the line width as 3. And then we can define the title of the graph. For example, again we have to use the same by Matplotlib library. Here we can define the title here, right? So again, now since we have already plotted, now we can define title. The title of the graph should be suppose graph, or we can name it as matplotlib graph. We want to call the title as Matplotlib graph. What we want to call what exactly we want to use as a part of y-axis. We can define the y label. So we want to call the y label, suppose, as profit. We can call it as profit, and we want to term plot x label. We want to define for x label, we want to call it as, suppose, sales and profit. For example, you can name it as anything, right? So we have profit, and then we have sales, and then we can define for publishing the legend that we had specifically defined here as slope 1, slope 2. This can be defined as legends, and then we can use to define the grid as, now in which color here we want to define grid as in there should be multiple horizontal and vertical lines being displayed here. If you want that grid, we can simply keep it to true, or we can define it to false, right? And what kind of color we want to use there? We want to use a simple black color. So we can define the color scheme as a simple K color scheme, as K stands for black, right? And then we can simply show the plot here by using plot.show, right? And as you can see currently, if we simply execute the entire command here, now this is the entire x-axis sales, these are to the legends, and this is the entire graph that we have currently displayed on top of the metrics that we have shown as a part of Matplotlib graph. So again, these things can be used, these things can be simply used for making sure we do have the entire graphical representation done from the data set that we have as a part of Matplotlib library available in Python. All right. Yes, we do have multiple other libraries available that we have for Selenium for web drivers, but now Selenium is basically used as a main tool for testing purposes, also in terms of Python libraries, right? That's what Python libraries are basically used for. So thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.